The Andromeda Galaxy is a majestic spiral galaxy composed of about 1 trillion stars. It is located at a distance of 2.5 million light-years from the Milky Way. It is so close to us that it is visible to the naked eye at an angular separation of just over 1 degree to the west of HD 4727, which is a binary star in the constellation of Andromeda. If its entire halo of gas could be seen with the naked eye, it would be about 3 times as wide as the constellation of Ursa Major, or the Big Dipper, and it would be the biggest feature of our nighttime sky. News about the already in-progress collision of the two galaxies came from a project called IGJ, Ionized Gas Around Galaxies Absorption, which uses the Hubble Space Telescope to study deep space around the Andromeda Galaxy. NASA calls this project the most comprehensive study of a halo surrounding a galaxy. As is commonly known, the Andromeda Galaxy, our Milky Way, and other galaxies are enclosed by a large shell, a so-called galactic halo, consisting of gas, dust, and scattered stars. With the help of the Hubble Space Telescope, researchers mapped out the huge shell of gas that surrounds the Andromeda Galaxy. They were astonished to find that this thin, almost invisible halo of diffused plasma extends 1.3 million light-years out from the galaxy, about halfway to our Milky Way, and for 2 million light-years in other directions. This means that Andromeda's halo is already coming into contact with the halo of our galaxy. They also discovered that the halo has a layered structure with 2 main layers and a separate shell of gas. Understanding the huge gas halos surrounding galaxies is of crucial importance. This reservoir of gas contains the material for future star formation in a galaxy, as well as the remnants from events such as supernovas. It is filled with clues to the past and future evolution of the galaxy. It became clear that the inner shell, which stretches out about 500,000 light-years, is much more complex and dynamic, while the outer shell is smoother and hotter. This difference is likely the result of the activity of supernovas in the galaxy disk having a more direct effect on the inner halo. However, since we live within the Milky Way, it is not easy to deduce the profile shape of the halo of our own galaxy. It is presumed that the halos of Andromeda and the Milky Way must be very similar since these two galaxies are also incredibly alike, both in relative size and appearance. Modeling the movement of the galaxies has indicated they are both on a path to collision and will merge, forming a giant elliptical galaxy in about 5 billion years. However, their weak halos have already begun to come into contact with each other. Thus, we can say that the merger, although almost insignificant now, has already begun, and there is no force that can stop this merging. The question then becomes, what will happen to the galaxies if they are viewed from the side? In a collision, large galaxies absorb smaller ones entirely, which practically does not affect their structure. However, when galaxies are close in size like the Milky Way and Andromeda, the collision causes their structures to collapse. A number of stars will be ejected from the galaxy, while others will be swallowed up by the merging of supermassive black holes. At the same time, the beautiful spiral structure of both galaxies will be disrupted, and a new giant elliptical galaxy will form in their place. These kinds of mergers could bring about a small upsurge in the formation of stars. The collision of galaxies forms vast hydrogen clouds, which can trigger a series of gravitational collapses. In addition, such mergers can be responsible for the premature aging of galaxies, as most of the gas turns into stars. After a burst of star formation, the galaxies run out of fuel. The youngest and hottest stars explode as supernovas, and all that remains are the old, cold, red stars, which live for a very long time. This is why giant elliptical galaxies, the result of collisions, contain so many red stars and so few active star-forming regions. By the way, the merging of black holes will cause orbital energy to be transferred to the stars, which will subsequently move the stars to higher orbits over millions of years. When two black holes come within a light year of each other, they will start emitting gravitational waves. The gas caught up by the combined black hole could create a glowing quasar or active nucleus at the center of the reformed galaxy. Finally, an effect of the merger of black holes can be to give a good cosmic kick to some stars, which will become genuine castaways taking their planets with them. Who knows? Maybe the universe will cast us off. The collision of galaxies is an event of truly grandiose proportions. These kinds of cataclysms will happen to any galaxy as soon as they inadvertently graze each other. In some cases, the galaxies merely brush each other in passing. In others, direct impacts follow like a head-on collision of cars, decisively changing the appearance of both objects forever. How will our galaxy look in billions of years? Time will tell, but it will be a completely different, unrecognizable world.